Welcome to all of you. In this session, we are going to understand how the given set of values can be arranged in the ascending order. Let us go through the question. Write an ALP to arrange the numbers in ascending order. Let us first consider an example. It consists of total 5 numbers, and these are all the set of numbers what we have considered, and the values under consideration, as we can observe, is total in a descending order, and we are going to perform the ascending order operation. So we are going to make use of the bubble sort procedure to perform this operation, right? So totally in this procedure it consists of two separate iteration. So one we call it as the external iteration and one more we call it as the internal iteration. So in which iteration we are present, that you can observe from this point as well as from this point, right? So once we enter into the external iteration, then the internal iteration is going to run for n minus 1 number of times, and that will keep decreasing after one external iteration. Let's have an observation of that in the course of the explanation, right? So in the first internal iteration, so these are all the values we have taken. So first two values are compared. So 5 and 4. So 5 is higher value, 4 is the lower value. Therefore, there is an exchange between those two values. This is first external iteration as well as the first internal iteration. Now in the second internal iteration, the value at this position, that is 5, and the value at this position, that is 3, those two are being compared. Here again 5 is the higher value. Therefore there is an exchange between these two values. After that we are going to get this representation. Then 5 and 2, the next values are being compared. In this case also 5 is the higher value, 2 is the lower value. Therefore there is an exchange between these two values, and after that this is what we are going to get. So in the last internal iteration, so 5 is compared with the remaining value, that's the 0 1, and in this case also 5 is the higher value. Therefore again there is an exchange between these two values, and 5 is moved to the bottommost area, right? Now we can make an observation that, so after the completion of the external first iteration, so one value has got settled to its position, that is the highest value 5 in the given set of array. So that has settled to its actual position. So next procedure, when we start with the external iteration 2, we need to verify the remaining 4 values only. We are not going to make any further verification with respect to this 5. Now this is external iteration 2. Within that, these are the internal iterations. As we can observe in this procedure, same procedure is being repeated here. So 4 and 3 is compared, 4 is higher. So make a move of it, make an exchange of it. Then this will be the procedure, this will be the second internal iteration. 4 and 2 are compared. So 4 is higher, again make an exchange of this. This is what we are going to get. Then again 4 and 1 are compared. So 4 is higher, again make an exchange between these two, and this is what we are going to get. So as we can observe over here, so after the completion of second external iteration, so we have sorted two elements, that is 4 as well as 5. So in the next external iteration, we have been left with only 3 values to be sorted. Now this for the external iteration 3. So here, so 3 and 2 are compared. 3 is higher value. So there is an exchange between those two. That's what we can observe here. In the next one, 3 and 1 are compared. 3 is higher. So again we can exchange between these two. This is what we are going to get. So 3 elements are being sorted, remaining only these two. So you have to keep observing that as external iteration proceeds, the internal iterations are being reduced. Now in this iteration, so 2 and 1 are being compared. So 2 is higher, so make exchange between these two, and this is what we are going to get. So as we can observe, so 4 elements are all sorted, remaining is only one element. Obviously that must be the minimum element. There is no more elements left to compare with this one. Therefore this is what finally the sorted numbers. So as you can observe, n value is equal to 5. That means number of elements that we considered was equal to 5 after how many total external iterations we had run. So we had run n minus 1 external iterations in total. So after sorting, so this is what the values we are going to have. Before getting into the program, let us first understand this one particular instruction which we are going to use in the program. CJNE A comma B comma R address. So here I am taking the registers A and B in particular because same is being used in the programming part, right? So now what this instruction is going to convey? So compare the contents of the A with the contents of B. If not equal, then jump to relative address. Relative address means whatever the label that we are going to use in the R address location, that's what the relative address. Then further, set the carry flag is equal to 1 if A is less than the contents of B. Otherwise, set the carry flag to 0. Right? So this concept we are going to use in the programming part in order to perform this sorting procedure. Let us get into the programming part. So here you can observe, so the values what we have taken in the example, same values are already been loaded to the memory location 5, 4, 3, 2, 1. It is in descending order and we need to perform here the ascending order operation, right? So R7 register is for external loop operation, and then R0 in order to locate the array of elements we are using this R0, and R6 we are using it as a internal looping operation. So now let us get into the execution part. So first R7 will be loaded with 05. So that means 5 elements we are using. Therefore it will be loaded with 5. So R7 loaded with 5. So n minus 1 iterations are required. Therefore we are decrementing R7 by 1. So now it is 4. Now we need to load R0 with the value 30h so that it can become the memory pointer later. So it is loaded with the value 30h, and then we need to copy the contents of R7 to the R6, which cannot be done directly. Therefore this 50h, a temporary memory location, is being used. So first the value will be copied to 50h, then 50h to the R6 we are copying. Now take the first element pointed by R0 to the accumulator. Then we need to take the second element for comparison. Therefore incrementing the R0 first and then taking the second element to the register B. Now register A consists of 05, register B consists of 04, and we are performing the comparison between those two register contents, right? So compare jump if not equal A comma B to next. So these two are not equal, therefore it will go to the next location. So next label is over here. In the next label it is going to verify for the existence of the carry. So this is a logical operation. CJNE is a logical operation where internally it is going to perform A minus B operation. If A is less than B, then it is going to generate a carry, right? So for that purpose we are verifying the carry over here, carry flag over here, right? So let us just expand this PSW and verify carry generated or not. In this case, remember, A is equal to 5 and B is equal to 4. Carry is not going to generate in this case because A is higher than B. So make a verification. So now here we can observe Cy is equal to 0. Carry is not generated. So if carry is generated, then it's an indication that need not to be make any exchange. So we can continue further. In this case, carry is not generated. Therefore, we need to make the exchange operation between the contents of the memory location 30H and 31H. In the other sense, between A and B. Right? So we need to deal with the memory location. So between 30H and 31H contents needs to be exchanged. That is being done over here. So let us see that. So contents of A has been moved to the location R0, need to be moved. So now it has been moved, as you can observe over here. So 5 has moved to this location, and then decrement R0. So now R0 will be pointing to 30H. This first location needs to be updated. To that location, content of B we are moving, which is equal to 4. So it has got updated. And then increment R0, we need to come back to this location. So increment R0, then decrement internal counter, that is R6. If it is not equal to 0, back move to the label up. So again we came over here. Now the values to be under consideration for the second internal iteration is the value 5 is compared with the value 3. So accumulator consists of the value 5 and register B must consist of the value 3. So let us have a verification of that during the course of execution. So now move A comma at R0. So now A consists of the value 5, increment R0. Now move B comma R0. B consists of the value 3. Now perform the comparison operation. So now again 5 minus 3 is going to perform. So 5 is higher than 3. Therefore no carry is generated over here. If carry is not generated, then we need to make the exchange operation. So now perform the exchange operation here also. Now decrement R6, and again as you can observe the 5 is moving downwards. So again start the procedure. So now again A is loaded with 5, B is loaded with the value 2. Comparison will be done between 5 and 2. Now so again 5 is greater, therefore perform the exchange operation. Decrement the R6. R6 is still not equal to 0 because there is one more element to be compared. So now load A with the value 5 and then B with 1 and make comparison between them. So still 5 is greater, therefore there is a exchange between those two memory location contents. So this completes one internal completion of one internal looping, arranging in such a way that one value has moved to the last location where it is supposed to be moved. To that location it has got moved. So in the next iteration we need to have next external iteration. So that is what we are going to perform here. So external iteration, now R7 will be decremented by 1, right? Now R0 again loaded with the further value. So that means now here we can observe that. So one value has got moved to its position. How many remaining comparisons we need to make out? We need to be remaining with 3 comparisons to make out in order to sort the next value, that is in the second external iteration. So internally 3 comparisons we need to be done. So again R6 is updated over here. So R6 will be loaded with the value 03. Right, whatever the external iteration value is there, that will be the starting value for the internal iteration. So now same procedure is repeated again. So as you can observe, the value 4 is moving downwards. So I'll be moving this at the faster rate so that we can complete it at the earliest. So the next one, right? So as you can observe, the third external iteration is running. So now, right, the last external iteration it is taking. So now it is going to sort out the value between 2 and 1. So 2 and 1, 2 is higher, so exchange. Now all the iterations are now getting completed, right? So all the iterations are completed, execution is going to end here. So as we can observe in the memory location, so values have been sorted in the ascending order. Thanks for joining.